Hey! My name is Jesus Castillo, and in this video you are going to learn about I/O in Ruby. I/O. This is a very interesting and exciting topic because input and output is everywhere, right? So your computer is an input and output machine. Your cell phone is also input and output, and even a plain old calculator is based in this I/O model. So of course, if we are going to talk about I/O, we have to define what it is. So I have this mind map, as you can see, and the first thing is that I/O stands for input output. Okay, now we have to go a bit deeper than that and explain what's input and output, right? So what is input? Well, the way I like to explain this is with some examples. So input is what comes into something. So for example, when you are pressing keys on your keyboard, that's input. That's input that you're sending into your computer, right? Or when you are clicking and moving your mouse, that's also input. But there is also input for your mind, like the books you read, right? So that's input. Input is what comes into something, and output then is what comes out as a result of the input. So for example, if I have a calculator and I press 1 plus 1 as the input, what comes out is of course 2, and that we call the output, right? Another example is a coffee machine. If you have a coffee machine and it has everything it needs to work, then you can press a button, right? And what comes out as the output is the coffee. It's an actual is the coffee that you can drink. So that will be the output, and the input of the coffee is of course water, coffee beans or coffee capsules, and probably electricity unless you're using some kind of manual coffee machine, right? So I think, yeah, I'm starting to get the idea of this input and output. And remember that input and output are often connected to each other. And in Ruby itself, input and output is manifested. It shows up in different ways, as we're going to see in this video. But one way is with methods. So methods that take parameters. The parameters or arguments, these are the input, and whatever the method produces, that's the output, right? I have one more example in here, and that's writing a summary from something you read. So if you read a book, you read an article, or you watch a video like this, right? That would be the input, and the output could be you writing a summary about what you learn, right? So that's input and output. Now that we have understood the concept, the idea of I/O, then we're going to see something more specific, which is the I/O class in Ruby. So in Ruby we have a class named I/O, right? Just like that, I/O, right? And it's the parent class of other I/O classes like file and socket. So we have file, right? You use the file class to read and write files. There's also a socket, which we need to require socket to get access to it. And socket is another form of I/O. What kind? Well, it's for network programming. What's network programming? Well, network programming is just when you're writing a server of any kind. It can be a web server, it can be an FTP server, whatever, an echo server. All of that works with sockets and I/O. So the good thing about this is, since these classes are inheriting, right, from the I/O class, they have a common interface for reading and writing to these objects, right? So when we say interface in the context of objects and classes and object-oriented programming, what we mean is the method, the public methods that we use to work with the class, right? That's the interface. It's just the set of methods that the class has. So what this means, how this translates into practical, is that you write a file the same way that you write a socket. You read a file the same way that you read a socket or any other I/O object. That's what it means to have common interface. And finally, an I/O class works with file descriptors. Okay, so I'm going to show you an example, and we're going to define file descriptors in a moment. But let's go to a code example right here in IRB. Using the base class I/O, usually you use one of the other classes like file or socket, right? Or even string I/O. But for this example, I want to use the base class so you can see how it works. Okay, and for this, first we need to call the sysopen method. Sysopen. Okay, and this is going to give some number, an integer. I'm going to call that fd. And then I'm going to open something. I'm going to open dep-null, and dep-null is just like a black hole, right? It's just a device on Linux, and I believe on Mac as well, that you can use to send anything you want, and it will not matter, it will be discarded, right? And I'm going to open it as write mode. So there are different modes that you can use to open one of these files. And what I get is a number, right? I get the number 10. What does this mean? What does this name represent? And why is this number useful at all? Well, here is where we come to this part, to the file descriptor. So a file descriptor, to understand it, we have to understand that every process, like Ruby or any other process like your web browser, that's also a process, your terminal, your editor, every program, right, is running as a process. And every process has a table that maps open files to an integer value. So that's why we get this value. This 10 is mapping this file to this number. Okay? So that's what's going on. Now, file descriptors are often abbreviated FD. That's why I use FD as the variable name. Usually I don't recommend to use abbreviations or very short names for your variables, but in this case I think I would make an exception, because everyone that's familiar with file descriptor and IO should know that FD is file descriptor, what it is. But just don't use that as an excuse to start giving bad variable names to in your code, right? Also, this is just an example. So if you really like, you can do the full name. So you can do file descriptor, right? So that's that. So one thing about these file descriptors is that they are unique for each process. So this 10, it means one thing for this IRB session, but this 10 might not mean anything for my editor, for example. Or it might mean a different file. It might have a different file associated or mapped to this particular file descriptor value, right? Before we do this last point, I want to show you how you can actually see this file descriptor, because there's not something that's hidden, or it's not something that's just a magic number, right? Something that you can actually see. How? Well, if you're using Linux, or this might work on Mac, probably not on Windows, so sorry Windows users. You have to use another tool, which there is a tool to also do this. I think it's called FileMon, like that, FileMon, something like that. That's for Windows users, or something like that. But for Linux and Mac users, what we can do is to use the following command. Looks like this. So let me break it down for you. This ls, which is for listing files, lh, which means list in human size, so this is for the file size. Instead of bytes, you get megabytes, you get kilobytes, etc. And finally, we have this part. And what this is doing is that in Linux, we have the proc file system. So maybe this syntax is different in Mac. I can test it for you. You can do a Google search for how to find file descriptions in Mac. But in Linux, we can access the file descriptors using this syntax, right? So this will be replaced by the process ID for this IRB session, which we can actually find if you want. Process things to is like this, process PID. So PID stands for process ID, right? And if I do this, oh, we get a lot of output. What is this? Well, this, I have multiple IRB sessions open, so we have to actually give the proper number, and there we go. So what we are seeing here, what we see here is a list, the internal list of these file descriptors. As I said, there is a table that maps between open files and integer values. And this is that table, right? That's how you get the table. So the number has to match the process ID. And here we can see 10. You see? So this 10 to them null, we can see represented in here 10 them null. Ta-da! So there is the mapping. And thus when we use this IO object, so I now can do this IO.new fd, which is 10, and now I can write into this IO object. I can do hello, and that goes into this file, which is not actually a file, it's just like a virtual device that Linux creates so you can send random things into it, used for things like this. It's also used for filtering output in logs, things like that. But that's besides the point. The thing is that we can create an IO object with given one of these file descriptors, and now when we write to this IO object, we are writing to the map file or the associated file. And now you will also notice something, is that there are a few things that don't look like files. So these are not files either. These are also virtual devices that connect to the terminal. So the terminal is this thing where I can type, right? Can type IO whatever, IO.class. This is the terminal, and the way we communicate with a terminal is using these virtual devices. And then these pipes are for, I'm not sure which specifically what are these used for, but pipes are another IO thing, another input-output things that is called inter-process communication, IPC. So that's one way that two different processes can communicate. And that's why we have these pipes. And finally, the final point is that every process starts with 3 standard file descriptors. And these are called std, standard input, std in, standard output, and standard error. So standard input, standard output, standard error. And these correspond to file descriptor 0, 1, and 2. So these 3, these are open automatically by the operating system, right? And you can access them from Ruby. In fact, there are constants std in, std out, std er. And it's not a surprise that there are IO objects. As you can see, if we do .class, there are IO objects. What are they used for? Well, glad you ask. So when we print something like eat some oranges, what's going on in here? Well, we are printing, in fact, to std out. So remember how I say that some of these virtual devices connect to the terminal? Well, that's how the terminal input and output works, right? So when I actually type something into IRB, this goes into one of these, right? And when we see something like this text right here, that's also one of these file descriptors. So as you can see, input and output is everywhere, even if you don't notice, but now you can start to notice now that you know how this works. And standard error is for printing errors, right? In Ruby, there is 2 ways to access it or to use it. One is you can do stdr.put something, right? Or you can do war, which I think is a lot better. It's the same thing. So that's an overview of I/O in Ruby. You know, it's probably a lot of information if you never hear about these topics before. But the most important to remember right here is what is I/O. It stands for input output. Input is what comes into something, pressing keys on your keyboard, and output is what comes out, what you see on the screen, the result of some mathematical operation, the result of a Ruby method, the result of using a coffee machine that's ready with everything it needs, right? That's output. So if you just remember this, that's pretty good. And then to go deeper, it's also interesting to remember this I/O class and file descriptors. Okay, so that's it for this video. Please click the like button for me so I know that you like it. And if you want to keep learning, watch more of my videos now, subscribe to the channel if you haven't yet, and visit my website rubyguides.com. rubyguides.com. Thanks a lot for watching. I will see you in the next video.